Today we're going to review the real number system. This is important for being able to classify types of numbers. So we'll go ahead and we'll start with the most specific category, which is natural numbers. Natural numbers are also known as counting numbers. Those are numbers that you would be able to count on your hand. So that would be any numbers between 1 and infinity. So that would be 1, 2, 3, all the way to infinity. These numbers do not have decimals. They do not have decimals. So I'm just going to go over a few numbers that we would want to check. So sometimes the numbers are already written, like 1, 2, 3, 4, etc. But sometimes we have to simplify a number we're given. So if we were given, for example, the square root of 36 is 6. So the square root of 36 would actually go into counting numbers. Likewise, we might see something like 10 divided by 2, 10 halves, and that 2 would go into counting numbers. Finally, we might see something like a percent, such as 900%. Remember, if you don't remember how to do a percent, we always just divide by 100, so 900 divided by 100 is equal to 9, so 900% would also fit into natural numbers. If we were thinking about comparing natural numbers to something we know in real life, we could compare it to my classroom. So we could always think natural numbers is like Miss Holland's classroom. We are all in my class. So natural numbers is the most specific category, and everybody in the we will think of it as similar to Miss Holland's class. The next category on the real number system is whole numbers. So we could consider whole numbers to be like something similar to the 8th grade. You are all in my class, and you're also all in the 8th grade, but not everybody in the 8th grade is in my class. Whole numbers contain all natural numbers as well as the number 0. So whole numbers is all natural numbers and 0. So again, a natural number or a whole number would be a natural number, so it would not have a decimal. It would be 1, it could be 50, it could be 100, it could be 300. But the smallest number in the whole natural numbers would be, or in the whole numbers would be 0. So I'll give a couple examples. We could have 300, we could have 50, but we always have 0. Again, all natural numbers are whole numbers, but not all whole numbers are natural numbers. The next category, as we get larger, will be integers. Integers are all whole numbers and their inverse, so all positive and negative numbers without a decimal. And of course, 0, because 0 is a whole number. So in this instance, our integers could be negative 50, positive 100, negative 75, 0 goes in the integers category as well. We can think of integers like linear middle school. All natural numbers are also whole numbers, just like all of you in Miss Holland's class are in the 8th grade. All whole numbers are integers, just like all of us in my class in the 8th grade go to linear middle school. Not everybody in linear middle school is in the 8th grade. We have teachers, we have other students, maybe 7th graders, administrators. They all go to linear middle school and they belong at linear, but they do not belong in the 8th grade. So again, if we are in the smallest box, we can be in all the boxes. But if you are in a bigger box, you may not be going down. So it's really important when we're looking at numbers to decide which is the smallest category that it would fit into. Our largest category here in the real number system are rational numbers. Rational numbers are everything we've already talked about and decimals. Rational numbers are include decimals. However, with the decimals, there are several types of decimals it includes. Decimals that end, and decimals that have a pattern. Okay, so some examples of these kind of decimals would be 2.573. This decimal ends. It doesn't go anymore. An example of a decimal with a pattern might be something if we saw 1 divided by 6. If I check in my calculator, 1 divided by 6, or 1/6, is 1.66666. It rounds on my calculator to a 7. However, it would just be 6 forever. So we would write that as 1.6 repeating. If you see this repeating sign, it belongs in the natural numbers. It belongs in the rational numbers. Again, we can try something else. If we see, say, if we saw a number like 3.5252, and it just kept doing 52, 52, 52, that pattern, that would be a pattern again, and it would belong in the rational numbers. Rational numbers can also be negative, and all numbers, again, from the counting and natural numbers, whole numbers and integers are also going to be rational numbers. So we could have like 0, -3, 56. They all fit. If they are in the smallest bucket, they're going to fit in all of them. We can consider, if we're considering it with our school, again, we can consider rational numbers to be Fairfax County schools. Or Fairfax County in general. We probably know people like our family members who live in Fairfax County, but they don't belong in linear middle school. They're not in the 8th grade, and they're not in our class. So again, you are like a natural number. You're in my class. You're also in the 8th grade. You go to linear middle school, and you live in Fairfax. Now, we've done about most of the numbers you're going to see, but there is one more thing. What happens when the decimal does not end, when it does not have a pattern? So that would be on a number, for instance, if we did the square root of 5. The square root of 5 is this number. It goes to the edge of my calculator. If my calculator window was bigger, it would still keep going. It would be larger. It would go on forever and forever and forever. There is no pattern. It's just sort of a sequence of numbers. I can't predict the next number. When we have an instance like this, so like the square root of 5, that number would go into what we call irrational numbers. Irrational numbers are decimals without end or pattern. So the square root of 5 is an example. So is the number pi. So if we see something like 5 plus pi, that number will go on forever. If we see something like 35 divided by pi, that number will go on forever. So generally, like I said, or not generally, always, like I said, if the decimal does not have an end or if the decimal has a pi in it, we know it's going to go on forever. We can do another one just to check. We'll do the square root of 11. That one again goes to the end of my calculator. There is no pattern, so I know the square root of 11 is going to be an irrational number. We can compare, as we're considering places we know, we could consider irrational numbers like Arlington County. People who live in Fairfax, they do not live in Arlington. If you go to Lanier, you do not live in Arlington. If you're in 8th grade at Lanier, you do not live in Arlington. And if you're in my class, you do not live in Arlington. However, all of these are real numbers, both irrational and rational. So real numbers would be like Virginia. So again, it's very important for us to be able to know that we need to know the most specific place a number would go in order to place it. If it's a natural number fits into natural, whole, integers, and rational. If we had an integer, we would fit into integers, rationals. Oh, and they're all real again. Everything is real. So a natural number is natural, whole, integers, rational, real. Integers are integers, rational, real. Irrationals are only irrational and real. Okay? So that's the real number system. It takes a little time to learn it, but once you've sort of got the hang of this, you'll be able to place these numbers pretty easily.